Hi, I am Chanchekar Gupta and we are discussing programming concepts. In the last video, we have discussed about trees. In this video, we are going to discuss the different possible ways in traversing a tree and listing out what are all the elements or the data existing in that present tree. Let's have a look. This is a tree, and for any tree, we are having in-order traversal, pre-order traversal, post-order traversal and also level order traversal. In the case of in-order traversal, the top node is called root, this is left node and this is right node. It should start with left, root and then right. Pre-order traversal starts with root, left, right. Post-order travels with left, right and root. In all these things, only the position of root changes. In the pre-order traversal, it starts at the first position. In the in-order traversal, it moves to the second, and in post, it moves to the last position finally. So, if you are having a pre-order traversal of 1, 2, 3, as it has started with root, 1 is the root of this entire tree. If you have the post-order traversal of 3, 1, 2, as it is ending with the root, 2 is the root of this entire tree. If you want to write in-order traversal for this tree, it starts with left, root and right. 2, 1, 3. Similarly, pre-order traversal 1, 2, 3. Let's also write post-order traversal. Left, right and root. So, 2, 3, 1 respectively. If someone asks you about converse orders like converse in order, converse pre-order, converse post-order, you can just interchange the position of left and right and everything will be the same. And the level order traversal is to list in levels. This is level 0, level 1. So, it is 1, 2, 3. If you have more levels, you will just continue this process. In this case, as we are having only 3 nodes, we have written all these traversals very easily. But how do we write all this traversal mechanism when we are having more number of nodes? Let's try to discuss it with the help of an example. Before discussing it, I want to introduce you to a term BST, which is called as binary search tree. There is a difference between binary tree and binary search tree. That is, if you take the root, all the elements which are less than the root will be present to the left. All the elements which are greater than root will be present to the right. This happens in the case of binary search tree, but in the case of a binary tree, you can insert it in any order. Let's try to build binary search tree with the help of the given example. Initially, my root is 50. So, I have started with 50, then 20. As 20 is less than 50, I have to insert it in the left side. 60 is greater than 50, it has to be inserted in the right side. Everything has to be compared with the root. Now, I am having 70. 70 is greater than 50. Now, 70 is also greater than 60. So, 70 will be inserted here. 25, less than 50, greater than 20. Similarly, 36. 50, 25, 36. 85, okay. 92. So, I am having 92 here. 65, greater than 50, greater than 60 but less than 70. So 65. This is the way you try to convert a sequence into binary search tree. There will be questions possible on this binary search tree asking whether the tree structure is valid or not. Then you have to check whether it has followed all the rules. Starting from the key, all the elements on the left side is less than the root element and all the elements in the right side are greater than the root element. If you want the least of the entire tree, you can just go to the last in the left side. So, this is the last element in the left side. So, 20 is the smallest element. Similarly, if you want the largest element, you have to go to the rightmost. This is the final and largest element. So, 92 is the largest element in this tree. This is the way in which binary search tree can be used, and it is very helpful when it comes in terms of search. Now, we will try to take a simple example and we will try to write all the tree traversals that we have discussed earlier. Is it a full binary tree? In the case of full binary tree, we are having 0 or 2 children for every node. But here, for this node, we are having only 1 child. So, it is not a full binary tree. Whether it is a complete binary tree, it has not been processed sequentially. If 20 was on the left side, it would have been a complete binary tree. But in this case, as it is not filled in sequence and it is not complete, it is not a complete binary tree. Whether this is a perfect binary tree, in the case of perfect binary tree, we are having 2 conditions. First one, all internal nodes should have 2 children. All leaves should be at the same level. But here, all these leaves are at the same level, but this is not having 2 children. So, it is not even a perfect binary tree. In this way, you will try to identify whether it is full, complete or perfect binary tree. Let's come back to the point of tree traversals. The first and foremost step in tree traversal is make 2 branches for every node. Why I have made this is, if we have a node, let's say A is a node and it is having 2 branches. Now I need to perform traversal on A such that I will perform it top down and left to right. In this mechanism, when I first visit A, I'll include it in pre-order traversal first time, and when I visit it second time over here, I'll include it in order traversal. Similarly, when I finally see A and I'm leaving this node for the third time, I'll include it in post-order traversal. This is an easy approach in which you can build pre, in and post-order traversals easily. Let's try to apply the same approach to this tree and let's solve it for these three traversals. Let me write pre-order traversal. If you remember, pre-order traversal has to be written when I visit the node for the first time. So I have to visit it top down and I have to visit it left to right. I'll start from here. So I visit 10 for the first time, 10, and then I'm visiting 9, and I'm visiting 8, and then I'm visiting 8 for the second time. I'll leave it for now because in the case of pre-order traversal, only when I visit for the first time it matters. Now I'm visiting 9, 6 I have visited here for the first time. So 6 I'll write, 15, here I have not visited anything. Now I have visited 20 over here, and it ends. This is the pre-order traversal for this tree. Let's try to write in-order traversal for the same tree. In-order traversal should be written when we visit the node for the second time. So I have to start from top down to left to right. I have not visited any node for the second time yet. Here I am visiting 8 for the second time. 8 has to be written. And then I am visiting 9 for the second time. 6, 10, 15, 20, and that's it. In a similar way, let's try to write post-order traversal. I have to visit it top down, left to right. Now I have to make a node when I visit the node for the third time. First time, now I am visiting the node 8 for the third time. So I'll try to write it 6, 9, 20, 15, 10. If we just observe, these are the tree traversals for this tree. If you want level order traversal, 10, 9, 15, 8, 6, 20. Now we have seen how to write pre, post and in-order traversal for a particular tree. But if we have pre, post and in-order traversals which are given, can we uniquely identify a tree? Can we form the tree with the help of the combinations of these traversals? How can we do that? Think about it. Stay tuned to find out. In this video, we will try to understand how to uniquely identify a tree with the help of the traversals. Either they can give pre or post or in-order traversals, and based upon this combination, how we will be able to identify a particular tree and what are the different possibilities. Let's have a look. I want to write pre-order for all these trees. So I have to write it when I visit the node for the first time. I am visiting 1, 2, 3. 1, 2, 3. 1, 2, 3. Let me write for in-order traversal where I am visiting it for the second time. So I will start from here. I am visiting 2 for the second time. So 2, 1, 3. 3, 2, 1. 2, 3. Make sure that you draw branches for each and every node. 1. Let's finally write post-order traversal when I visit the node for the third time. 2, 3, 1. 3, 2, 1. 3, 2, 1. If we just observe, take these two trees, both of them are having same pre-order traversal and same post-order traversal as well. That means with pre and post, you can have multiple trees. If they have given out pre-order traversal and post-order traversal, many trees or multiple trees can be possible from it. If they have given pre plus in or post plus in, you will get a unique tree. Let's try to solve this with the help of an example. We have been given an in-order traversal and also a pre-order traversal. What we need to do was, we need to construct the tree. We know that when an in-order traversal is given with pre or post, we can identify a tree uniquely. But if pre or post has been given, we can have multiple trees. To identify a tree uniquely, we should have an in-order traversal and either pre or post traversal. Let's try to check the validity of this statement. We know that pre starts with root. So, at first and foremost, we will be having the root of the entire tree. 5 is the root. 5 is here. Now, 5 is located at this position in in-order traversal. Whatever to the left of 5 should be present to the left, and whatever to the right should be present to the right. This is happening because in the case of in-order traversal, we visit left first, we'll visit root, and then we'll visit right. But in the case of pre-order traversal, we'll visit root first, we'll visit left, and then we'll visit right. If we just see, we are trying to match the position of root, and then we are trying to identify which are left to the root and which are right to the root. Now, in the second stage, we are having 3. So, 3 is the next root in the tree. If you just look at the position of 3, 3 is over here. Whatever to the left of 3 should be in the left side. Whatever to the right of 3 should be on the right side. 3 is over here. 1 and 2 will be on the left side of 3 and 4 is on the right side of the tree. Now we are having 1. If you just observe the position of 1, 1 is over here and nothing is on the left side. So, 2 lies to the right of 1 because nothing is lying left to 1. 2 is the root here, but it is not having anything to its left or right as it is already distributed. Now we are having 4. So, here 4 is also a root here. Root in the sense it is the root for the subtree. If you take this tree and if you take this subtree, 2 is the root of this subtree. In that context, I am calling it to be the root and I am having 6. So, 6 is over here, 7 and 8 lies on the right of 6. So, 7 and 8 should be on the right. Now, finally, I am having 8. 8, I am having 7 to the left. This is the tree. I started picking from the first because pre starts with root. If I am having post, I have to pick from the end. Let's try to write post order traversal for this tree. We know that post order traversal can be written whenever we visit the node for the third time. Before that, I need to have 2 branches for every node. Let me try to make it. Now, I have to traverse top down and left to right. 2, 1, 4, 3, 7, 8, 6 and finally 5. With the help of this post order traversal and this in order traversal, we will try to construct a tree. Let's see whether the tree resembles this or not. If it resembles, then the statement that we have discussed, with the help of pre and in or with the help of post and in, a tree can be uniquely identified is valid. Previously, in the case of pre, we have identified root by going from the first. But in the case of post, we have to go from the last because post gives left, right and then root. So, this is the post order traversal. To identify the root of the tree, we have to go from last. 5 is the root of the tree. 5 will be on the top and 1, 2, 3, 4 is to the left of the 5 and 6, 7, 8 is on the right of the 5. Next, the root is 6. 6 is over here and 7 and 8 are to the right of it. So, 7 and 8 will be present to the right of the 6. Followed by that, we are having 8. 7 should lie left to 8. Now, the tree looks like. And next we are having 7. Here 7 is done. We are having 3. To 3 we are having 1, 2 to the left and 4 to the right. And then we are having 4. 4 is done. We are having 1. So 2 has to come to right. Let me bring back the old tree. This is the old tree and this is the new tree. This has been constructed with post plus in and this has been constructed with pre plus in. If you just observe, both of these trees are same. With the help of this, we'll be able to identify a tree uniquely with pre plus in or post plus in traversals. We have seen a lot about trees and it's the time to say goodbye. But before saying that, I want to discuss few words about binary search tree. When we are discussing about this binary search tree, it has some speciality over the binary tree. We are trying to store the elements in this binary search tree so that it becomes search efficient. For example, take a binary search tree. We have seen its construction in the video, right? Take a binary search tree and try to write in order traversal for the tree. You will try to observe that it may be the ascending order of the numbers that are present in that tree. That is the speciality of the binary search tree and it makes search much more efficient.